We're starting to get into kind of the trickier part where you have to do some thinking. We're not just doing math. So, in physics, as I mentioned, we're going to have to solve systems of equations. And you're going to have the choice of basically every equation on the formula sheet, plus some that you will write based on physics principles like Newton's second law, conservation of energy, conservation of momentum, which aren't written specifically on the formula sheet. And you'll have a certain number of unknowns. And on the AP exam, on the free response, they will give you something that says, solve for this in terms of blank, 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 and other things. What they're doing is they're telling you a checklist of what variables are allowed to be in your answer and what variables are not. Because all of our physics problems are going to be based on theoretical physical scenarios. What could we actually measure in the lab? And there's some things that we would be able to know easily because we could measure it, say, with a ruler, and other things that there's just no way for us to directly measure. Like we cannot directly measure energy. That's not something we can do. So a lot of times we have to use other variables to find energy, things that we can measure. So you don't know how to write these equations. You don't know what these equations mean. So what you're doing right now is looking just at the variables that you have, the equations you're given, and what you're allowed to have in your answer and what you're not allowed to have in your answer. So I've just picked three equations that are related to each other. And you are going to use these equations to try and figure out which equation do I have to start with. And are there variables that I'm not allowed to have? If so, how do I get rid of those equations and get that answer in terms of only the ones that are allowed? So in this case, we're solving for momentum. So the first thing I want to do is just pick one of the equations to start with that has what I'm looking for in it. Sometimes there's more than one equation, and you might have to try again if you pick the wrong one. In this case, we only have one equation that starts with a P. So I'm going to write that equation down first. P is equal to M times V. So then what I look at is I look at my variable list because if I know M and V and they're allowed to be in my answer, I'm done. Well, I see that M is allowed in my answer, but V is not. So I have to find a way to get V out of my answer. So then I look at the other equations on the formula sheet, or in this case, the equations that were given. So we have x equals v0t plus 1/2 at squared. Now I've got a v here with v0, but v0 and v are not the same thing. v0 means at the start, v means later. So that doesn't have a v in it. That doesn't help. But then I've got this equation over here that says v equals v0 plus a times t. So I'm going to bring that down. I'm not going to write it next to over here. Now, in this case, they are giving us some additional information to help us simplify our answer down. They're telling us V0, which is our velocity at the start, is 0. You will sometimes read the context of the problem. It'll say, oh, this object starts at rest, or it starts from the ground. They'll give you some initial conditions, or maybe some information later. It ends at the ground that can help us fill in these zeros and make our work easier. So in this case, they're telling us that our V0 is 0. So if I was to sub in a 0 right here, V is equal to 0 plus a times t. Well, 0 plus anything is just whatever that anything was to begin with. So that 0 goes away. So I just get V is equal to a times t. Now, I don't usually show my work like this. When I'm actually working problems, I will just draw a line with a 0 through it. So I'll just say, hey, this is going to become 0. That's how I show a substitution of a 0. I don't show it like this. It's too much extra writing that is kind of unnecessary. If what you have is 0 and it's multiplied by other things, remember 0 times anything or 0 divided by anything is still 0. So essentially anything that is touching what becomes 0 with multiplication or division, that whole term becomes 0. In this case, there was nothing multiplied or divided by V0, so just the V0 goes to 0. So I'm left with V is equal to A times T. So then I can take that V is equal to A times T, and I can plug it in over here for V. So once again, I'm using those arrows as a roadmap. I'm going to show that exact substitution. So I'm going to replace V with AT. I'm using parentheses to keep that AT together. Now, I don't actually need those parentheses for my multiplication, so I'm going to rewrite it as m times a t. Now, that would be wonderful if t was allowed in my answer, but I don't see a t here in my answer. A's fine, but t is not. So I am going to need this fourth equation. So I'm going to take that fourth equation, I'm going to move it down over here. X is equal to V0t plus 1/2 a t squared. When you practice writing your letters, one of the things I told you to do was to make sure you show the difference between a T and a plus sign. You should always make your T with a curve. Please do this now. I will give you lots of reminders, but start doing that now. Okay, there's a reason we're practicing that. It makes it a lot easier to interpret your handwriting and communicate clearly. So the other thing I know is that V0 is still 0. So here, V0 is 0. So if I was to show that 0 subbed in, I get 0 times t plus 1/2 a t squared. So this is what I was talking about. 0 times t is still 0. So this whole thing becomes 0. So I could have just right here, when V0 became 0, I could have just drawn that arrow with a 0, and then that term goes away. So x is equal to 1/2 a t squared. Now I'm trying to get rid of t, so I need to get t by itself. So one thing I'm going to do is anytime I have this fraction with my multiplication, to undo a fraction like that, I'm going to flip and multiply. So instead of dividing by a half, because I hate dividing by fractions, I'm going to multiply both sides by 2, because whatever you do to one side, you have to do the other. 2 times a half cancels. So I have 2x is equal to a t squared. My goal is to get a by itself. So what I'm going to do here is divide both sides. I'm going to, sorry, t by itself. So I'm going to divide both sides by a, because a is multiplied by t squared. So the a's cancel. So I get 2x over a is equal to t squared. Now what I want to do is I want to get t by itself, so I have to undo the square. I do that by taking the square root of both sides. Now, in general, anytime you take a square root on both sides, you get two solutions, but usually only one of them makes sense in terms of physics. And when I'm working in variable format, I don't use the plus or minus for my solutions when I'm plugging in a system of equations. Because if we were to have numbers, the numbers would take care of the answer itself. In a lot of cases, a negative time doesn't make sense anyways. So I'm just going to cancel that square on the right. So I get t is the square root of 2x over a. And then I'm going to take that t and I'm going to sub in over here. So p is equal to ma times the square root of tx over a. Now that answer would work. Because what I want to do is once I've gotten my answer, I want to double check to make sure I have only the allowed variables. I'm allowed x, which I have, a, and m. Now, just because something's allowed doesn't mean it has to be in there. There are times when a variable will cancel, and although it's allowed, it's not actually in your answer, and that's okay. This is also not very simplified, but if this was a test, that's probably what I would do, is I would just get there and be done. If it was a multiple choice question, however, that might not be my answer. That might not be an answer choice. If it gave you A, B, C, and D and different equations were different answers, that one might not be there. And that's because there's an A in two different locations. That's not really a proper way to kind of relate variables. So although this is not necessary, what you might often have to do is you might have to simplify it to make it look like the answer on a multiple choice question. So you have to do some tricks. So these are the tricks that you have to do to take care of this one. So I have p is equal to ma times the square root of 2x over a. So when I do this, one thing I notice is that there's two A's. I need to get my A's together. The easiest way to do that is to find a way to get this A that's out here inside the square root with my other A. And I can do that by remembering that if I have A, that's actually the same thing as the square root of A squared. Now that's really weird, but if I square root a square, it cancels. So A is equal to the square root of A squared. That's just saying A equals A. So I can replace that here. And what I get is I get P is equal to M square root of A squared times the square root of 2x over A. Now, why does this help? Because there is a rule with square roots that says the square root of x times the square root of x is equal to the same thing as the square root of x times x, or whatever you have inside. So basically, I can combine any sort of square root that is multiplied or even divided. So if I had the square root of x over the square root of x, that's the same thing as the square root of x over x. Those are the same thing. So I'm going to use that property of square roots, and I can rewrite this as P is equal to M times the square root of A squared times 2x over A. Now, how does that help? Because when I'm simplifying, if I have an A squared on top and an A on the bottom, one of those A's is going to cancel. Because if I was dividing like 2 squared times like 1 over 2, that is going to be the same thing as 4 times 1 over 2. 4 divided by 2 is 2. So essentially what I can do is that 2 in the square and this 2 down here, one of the 2's on the bottom cancels, one of the 2's on the top, that's reduced to a 1. 2 to the power of 1 is just 2. So I can simplify that way. So I'm going to do the same thing here. One of the A's on top and bottom will cancel. So the square will cancel, leaving with A to the power of 1. And this A on the bottom cancels, leaving me with a 1. But 2x divided by 1 is just 2x. And A to the power of 1 is just 1. So I get P is equal to M times the square root of A times 2x. And then generally we write numbers before we write letters. So I would, and you can do multiplication in any order. So I would rewrite this as P is equal to M times the square root of 2ax. And if this were a question on an AP multiple choice, that is most likely what your answer would look like. It would not look like this, although that's what your algebra would probably get you. So you might have to do additional algebra to make your answer look like the multiple choice answers. So not necessary in the packet. For the packet, as soon as you get your answers in terms of whatever you're looking for, when you've done your check of your variables, you're fine. You do not have to simplify down as far as it can go, although it's good practice if you want to.